So this will be the periodic table of the elements we have on the exam. But when we're trying to figure out how to name things or how to balance out formulas for ionic compounds, we need to know charges. And so what you should know, right, because each group has a similar reactivity, is some of the common charges for each of these groups. So group one, all of the group one, right, they want to lose one electron. And so group one will typically be found as a +1 ion. So sodium, for example, we saw that reaction with sodium and water. It's going to react to form sodium +1 by giving up one electron, by losing one electron. The same applies to lithium, potassium, rubidium, cesium. Group two, everything in group two, they've got two valence electrons. So beryllium, magnesium, calcium, strontium, and barium, they are going to react to form a 2+ ion. So anytime we see them as an ion in solution, right, magnesium, for example, solid magnesium would react to form magnesium 2+ because it loses two electrons, right? In general, our metals are our cations. They're going to be the ones that lose electrons. The last one we talked about was aluminum, all the way over here in group three. So again, these charges match the group number, group one +1, group two +2, group three for aluminum. Aluminum wants to be, when aluminum reacts, it wants to be 3+ as an ion. Carbon's kind of in the middle. It doesn't really want to lose. It doesn't really want to gain. Nitrogen will gain 3 electrons. Oxygen, sulfur, selenium, tellurium, all will want to gain 2 electrons, becoming a 2- anion. And then our halogens, all of our halogens want to gain 1 electron. Ultimately, they're trying to become isoelectronic. They're trying to become the same electron configuration as a noble gas, which is isoelectronic. So our halogens, they get there, right? Our halogens get there by gaining 1 electron, right? Bromine goes to bromide, picks up 1 electron. It's going to have the electrons of chromium. Chlorine goes to chloride. It picks up 1 electron and goes from 17 to 18. It's going to have the electron configuration of argon. So that's why our noble gases are all -1. Oxygen, sulfur, selenium, tellurium are 2- because for oxygen to become isoelectronic with a noble gas, it has to go from 8 electrons to 10 electrons. It has to gain 2 electrons, hence the -2. It'll get complicated in through here with the transition metals, right? We talked about iron in class as an example. Iron 2+ exists. Iron 3+ exists. We saw the same thing with copper, right? Copper +1, copper +2. But because it's complicated here with the transition metals, we should be able to work it out and figure out what the charge on the transition metal is based on what it's bonding to. And so in class, right, we worked through the example of iron 2 oxide that was just FeO, which is different than iron 3 oxide. Right, iron Roman numeral 3 oxide. If iron has a 3+ charge here, 2 irons at 3+ is +6. I balance that out with 3 oxygens at -2 each, which is -6. Again, we don't know what the iron that we're working with is, but we know oxygen, because oxygen is over here as a non-metal, it always wants to be 2-. So we use that to work backwards and figure out iron 2 oxide is FeO, iron 3 oxide is Fe2O3. So yes, we can't know all the charges of the transition metals, but we should know these charges of our nonmetals as ions and use that information to work backwards and figure out what is the charge on this transition metal.